channel. Now we're going to just look through the concept of cycloid and gravitational force on a car wheel or a wheel, and then we're going to get what the parametric form is. We're just going to state it and see the effects. What is a cycloid? It's a movement of a car wheel or a wheel. Remember when you play, for those of us that played tire when we were small, forget that we get like played tire. So we played tire when we were small. That motion of moving a tire from one position to another is what we are going to describe here as a cycloid. So, suppose that this is the ground, which we know as our x-axis. Without loss of generality, let this be the origin and let this be the y-axis. Assume that this is the tire, the wheel of the tire. Let this be the center of the wheel. You know the way tire is now. I don't want to do it because I'm going to scatter it in the end. Suppose that the radius of this tire is A.
Yes, ma'am.
What does it mean? It means that let's where this hits, let's call it Y. It's still Y axis. You can call it Y1, but you can leave it as Y. Huh?
That point is 2A.
If you want. Then let's call this. Do you know I don't want to do that because it's not always true that you start from the origin. Okay? So just leave it like that. If this moves from this position to this position, suppose that this arc from the center of this to the center of this, then we have that here is still A. This whole thing is A. And then we have that here to here, here to here, like this, is y minus A. Okay? Suppose that this moves at an angle of theta. Suppose that we have a car wheel moving from one point to another. The equation is represented by x is equal to A times t minus sine t, where A is the radius. The radius of this wheel is A. Okay? And then y is equal to A 1 minus cos t. If you want, you can take your time and derive it, where this angle is theta, and then you can take your t to be the whole of this. You have that since this is A, then this must be A because they are all radius. And then you have A, call this place Y, then the whole of this is Y minus A. And then if you check for the equation of the arc, you will see that the equation of the arc is AT. This place will give you x minus AT. Okay? Then you use that to solve. The next thing is to get what theta is in respect to t. We have that the whole of this is 3 over 2 pi. This is pi plus half pi. Okay? 3 over 2 pi. And we have that this 3 over 2 pi is comprising of t and theta. So what you have that theta is equal to 3 over 2 pi minus t. You plug your values in here. And you use your Pythagoras theorem to have that this is x minus at, this over this over hypotenuse, that's over A, is equal to adjacent over hypotenuse is what? Cos theta. So you substitute your value. You substitute theta to be equal to this into this, and you make x the subject of formula. You will get this. You should get that. And you substitute y, here, y minus A. That's the same thing as, sorry, place, which is y minus a. You have y minus a over the hypotenuse a is equal to, this is opposite, this is hypotenuse, you have sine theta. So you substitute your values and you get this. So you can take that as your own and you get this equation of cyclone. So that you have that your coordinate is x, comma y is equals to a t minus sine t, comma a 1 minus cos t. This coordinate.
So this is what now? This is the cycloid formula?
Yeah, this moves from a point xy to this new point xy as this.
Okay.
So whatever your starting point is,
Right.
it moves to this new
This
point,
new point.
depending on what your t is
And what you are is.
and what your a is. Okay.
If you wait for that,
Now a question for the gravitational force. We have it opposite. It's exactly this, but it's
the opposite direction.
this one is like this.
Yes.
This one is opposite. Okay.
Okay.
Now a question says that if I have my a tire starting from here, another one here, another one here, and they are going to meet the center, reach the center of this arc, considering gravitational pull. Which one will reach first? If this is A1, A2, A3, which one do you think will reach first? So they will reach at the same time.
Who? Who?
All of them.
All of them, be A1,
the A2, the
A2, 3 will reach at the same
They
time.
will reach them at the same time.
Yes, they reach that center of the arc at the same time. And this principle is called Tau Chrone.
Tau